Welcome. So we're going to answer this question before us. So we've been given this function f of x, and as you can see, we can immediately identify it as being a truncus. So it is a truncus. So that's what we're going to sketch before us, a truncus. So it says on the set of axes below, sketch the graph of y is equal to f of x. Indicate clearly the equations of any asymptotes and the coordinates of any axis intercepts. So just make sure that you're reading the question carefully and you know what you have to provide, especially when given a sketch. Okay, so the first thing that we're going to identify here are our asymptotes. So the fact that I know that this is a truncus tells me that two asymptotes are going to exist. This one right here, I've got x minus 1. So what that means is that x minus 1 cannot be equal to 0, otherwise the whole thing would be undefined. So that means one of my asymptotes is going to be x is equal to 1. So that means it's going to be over here. Now, as the question says, we need to make sure that we label our asymptotes with equations. So it's going to be x is equal to 1, just like that. The other asymptote you read off by looking at your vertical shift. So the fact that it's 2 up. So that means I'm going to have another one here at y is equal to 2. So as you can see, not only have I drawn in my asymptotes, but I've labeled them with the appropriate equation. The next thing that we need to consider is just generally what this thing looks like. And we know that a truncus takes this form right here. It looks like this. Now this is where you just have to make sure it looks like that. It's really important that when you draw this, that you're never touching your asymptote, but it's just like ever so closely getting closer to it. So it needs to look something about like that. Okay, having now done that, we need to find our intercepts. And as you can see, there's definitely one going to be there. So to find my y-intercept, so find the y-intercept, we let x be equal to 0. So that means I'm going to get y is equal to 1 on negative 1 squared plus 2. Y is equal to 1 plus 2. Y will be equal to 3. So I can come over here and I can label this 0, 3. Important, as it says, to label it with coordinates. And that's the only coordinate that we have there. And that's it. We are all done with our graph. So let's now continue on to the next bit, which says write down the range of f. Write down the range. Now, what is the range? What does that mean? Well, the range is simply all the possible y values. So all my possible y values here would be what? What would be all my possible y values? Well, hopefully you can see the very first time I get a y value is, here. It's everything above y is equal to 2. It exists everywhere above there. So that means I can come down here and I can say, well, it's 2 to infinity. Let's try to do that a bit nicer. Infinity. It's important that you have a round bracket on 2 because you're not including 2, are you? You're not including it because there's an asymptote there. It doesn't exist there. But everything greater, everything greater than 2 will exist. So everything greater than 2 will exist. And you can kind of see it just by looking there. It's going to exist for all of those values. So it will be 2 to infinity. All right, we'll pause here and then we'll go through part C in the next part. Hopefully everything so far has made sense.